Namaste and welcome to the course of Design of Machine Elements. In this shaft section, we have learnt if at all a pulley is being loaded at the mid of a shaft, how to design the shaft. If a gear at a mid, how to design. Two pulleys on a shaft, how to design, and two gears on a shaft, how to design. In this video, I will let you know how to design if a one pulley and a gear is loaded on a shaft and how to come up with this. Right? Ready with the paper pen? Let's start it. Therefore, so this video, gear and a pulley loaded on a single shaft. So I'll be considering this particular case for which a horizontal commercial shaft is supported by two bearings 1.5 meter apart. A 20-degree involute gear of 175 mm pitch circle diameter is skewed to a shaft at distance of 400 mm to the left of the right hand bearing and is driven by the gear directly behind the shaft. The direction of the rotation of the gear is such that the tangential force acts vertically downwards. A 600 mm pulley is skewed to the shaft 600 mm to the right of the left bearing and drives a machine pulley with a horizontal belt rod directly behind it. The ratio of tension in the belt is 3:1. The drive transmit 45 kilowatt at 330 rpm. Take Cm is equal to Ct is equal to 1.5. Neglect the effect of keyways. Can you note this? And the weight of the gear and pulley. Determine the diameter of the shaft. If the allowable shear stress in the shaft diameter is limited to 40 MPa. Also calculate the angular deflection in degrees in the shaft by taking the modulus of rigidity as 80 GPa. Now, as I said that, dear students, kindly go through the case once or twice and then come up with a conclusion like what to be done and what not to be. So for which I will be going up a light front-view sketch of a system which has been given to me. So which I said that yes, a horizontal commercial shaft is supported by two bearings. I say this A and D are the two bearings which is of around 1.5 meter apart. Okay. Next take further, a 20-degree involute gear of 175 mm pitch circle diameter is keyed to a shaft at distance of 400 mm to the left of the right hand side bearing. So I consider this as a right side bearing. So left of that around the 400 as you can see over here 400 mm we had one gear. I call it as a gear C which is 400 mm. So further saying that a 600 mm pulley is keyed to the shaft 600 mm to the right of the left bearing. I consider this as a left bearing. So to the right of it, if it has been keyed to a distance of 600 mm, right? So whatever left back would be 500 mm. Okay. So this is an initial sketch of a system. So next, if I said what would be the givens that is being given to me, yes, pitch circle diameter of a gear is given 175 mm and alpha 20-degree involute, and further it says the diameter of the pulley is 600 mm. So the tension of those two T1 by T2 is equal to 3. Power is given 45 kilowatt and the speed N is given 330 rpm and CMCT which is 1.5 and tau D is 40 MPa and G is 80 MPa. And if you could remember what to find is D and theta. Now we can say that if I could remember the given, so side wave of that what I going to draw, that it's a gear which has been taken power and it says that the tangential force is vertically downwards. That's what I say here. It's a driven gear, the tangential force is vertically downwards and over which if I say vertically downwards the tangential force, affirmatively the radial force is towards the shaft. And then further I added a pulley which is delivering one more a power to one more pulley which is right behind it. So I call this as the tension of T1 and T2 respectively, and summation of those two would be T1 plus T2. So these are the in this sketch we can come to one part of conclusion at least how many types of vertical forces we do have and what are the horizontal forces and what are the vertical forces will come in existence in this case. So while next would be how the solution is. As I said that always in deriving the diameter of a shaft, I use this particular equation by maximum shear stress theory, the page number 43. So I am going to consider the according to maximum shear stress theory 3.6b equation. So same could I would pull in out. So I know the D naught is equal to the same equation 3.6b of page number 43. And we know that for solid K is equal to 0. So for solid shaft K is equal to 0. So remodulating this equation, what all I got this is 1. So this is the equation where I am going to use in order to find out D. In fact, I will find out all the other elements which are unknown to me, where the tau D is given, Cm is given, Ct is given, I have to know what is M and T. So next step, what I am going to find would be the torque. You know that from equation 3.3a of page 42, the same equation what we used in our previous videos. So I go over that, with the page number 42, the equation 3.3a where it says 9.55 into the power of 6 into P divided by N. Kindly note, very important here, the P need to be substituted in terms of kilowatt. So I'm going to pull down the same equation over here. Now substituting everything into it, so whatever the torque that I got is 1302272.727 Newton mm for this case. So this is the torque. So we know that both the systems have been loaded on the same shaft, so therefore we consider that both the torques are same for the both shaft and a pulley. So therefore the TC will be equal to TB, as you could see over here, right? So further right, in order to draw in a torque diagram, you know that for the TC is equal to TB, the value remains same. So this is a point A, straight line point A, and point B, and point C, and point D. You know that the torque at B and C states to be same. So vertical line of a same dimension, then join those and you look at there is a torque diagram what you need to draw. So further moving ahead, so bending moment, in order to find out the bending moment, so I like to know what all the horizontal forces and vertical forces. So for which you know very well that the vertical and horizontal force at pulley B, if I say that, there won't be any vertical force as if in a case it's clearly given neglecting the weight of a pulley. So therefore we won't consider they over it. So only the horizontal forces, you know, the T1 and T2, summation of those two would be T1 plus T2. So this is the one. Horizontal at B, FHB is equal to T1 plus T2. And you know that the torque at B is TB, where TB is equal to TC. The general equation states to be TB is equal to T1 minus T2 into D by 2. Now substituting all the values into it, I can clearly come out with an instruction what I had at T2 and T1. The T2 what I got here is 2170.4545 Newton, and the T1 is 6511.3636 Newton. So these two things, the summation of those two would be the horizontal force what I had, that would be the summation of these two values, which is 8681.8181 Newton, and the direction is towards that side. So this is the direction of this. You can see here, the direction of this and this remains to be same. Now further moving ahead, the vertical loads were at this pulley. Can you see any vertical load here? None, as if in a case it says that neglecting the weight of pulley. So therefore I will be neglecting that, so therefore the vertical load is 0. So next further ahead, the bending moment when it comes to a vertical horizontal force over a gear. So this is how it comes to be, the vertical horizontal force on this particular drive, and you can see here we do have one vertical force and one horizontal force over there. So if I say that, so what will be the vertical force? Therefore Ft is equal to 2mt divided by D. Now I can pull on the same equation over here, and if I draw this, the vertical load C is FCH, or we call it Ft, you know that 2mt divided by dt. Now substituting everything into this, the value what I got is 1483.116 Newton, and direction you can see here direction, and what all the direction that I took over here would be same. Now further right, for a horizontal momentum, you know that Ft into tan alpha from the equation. So same thing I'm going to pull down again. So the horizontal load at C would be FVC is equal to Ft into tan alpha. Now substituting, you know the Ft is known over here and the alpha is given. So substituting everything into this, so what all the values that I get is 5417.0115 Newton, and you know the direction over here which is then given over there, same direction I have been added over here. Now once we know what all the vertical forces and the horizontal forces, then to find out what are the vertical bending moment. So for which I will be considering a shaft with a length of A, B, C and D, B at a point and C at a point, B at a point where we do have a pulley, and C at the point where we have a gear at the distance of 600, 500 and 400 mm. So these are two bearings A and D. Now you know that we had already derived a vertical force which we had at the point C, and we don't have anything vertical force at the point B, so I didn't draw any force over there. Now the reaction forces RA and RB at both the ends, RA and RD. So now in order to find out, we know that very well that summation of all the forces over here, what are the forces moving up? I said this is moving up, and this force going downwards. So what are going up I consider as a plus, which is coming downwards I consider as a minus. So therefore the summation of all these forces, like RA, I don't have any RB, so this is coming downwards, so RA minus RC plus RD is equal to 0. This is the equation what I written over here. So now we are taking this particular moment, now summation at this momentum at point A, what will be the forces. Now you can see here RA plus RD is equal to what the value that I got over here, because I know the value RC is this one. Now summation of this momentum, as the equation that I written over there. So only one thing I had a force over here, which is 1488.3.116 Newton into, as is going into clockwise direction toward this point. So clockwise direction I will consider it as a plus into 600 plus 500, which comes under 1100, which is written over there. And this one RD, it rotates anti-clockwise towards this point. So minus RD into 600 plus 500 plus 400, which comes as 1500. This is the equation what I written here. Hope you understood this. So here clockwise, this load into the distance, here again RD into distance. What are the equation I come up with? So from this equation I can conclude with what is RD and RA. So I will write down the RD value and RA value over here. Now in order to find out the bending momentum at the particular points, so what I do is I am going to draw a similar length of this equal over there. Also this is the bending momentum at point A, you know very well it is 0 because here it do not have any force. So here this force into distance minus of the last force, I mean RD into this distance, surely it should be 0. That what has been given over there. So now the point at B, you know that at point B either I have been considering all the forces at the left side or the right side. So at this particular point what I am going to consider is this force. So 3968.83, since it rotates in a clockwise into distance 600 mm. That is what been given over here. So while doing this, the value what I got is 2381295. I am going to mark over there since it is a plus above it. Now at this point, as I said that either I consider all the left side forces or the right side forces. If I say consider the right side forces, so you can see here RA 3968.83 into 600 plus 500. It is a clockwise, I will consider this as a plus towards this point. So that is what I did over here. You can see over here. The value what I got will be this, and I mark this over here. Now similarly at point D, surely the system should be 0. Now joining all the lines over here, right, and I document it, this is a bending moment diagram what we get for vertical forces. Now next, in a similar way, in order to find a horizontal bending moment, this is how I do again a line, a shaft of so and so dimension with A, D are the bearings, B as in a pulley and C as in a gear. Now I know that the horizontal momentum force at B, one point would have an 8681. If you could remember my summation of T1 plus T2, that is the value over here what I written, and another would be C. This is another horizontal FR which will be derived, which is 5415.011 Newton. Now similarly the two reaction forces, one is RA and another one is RD. Now summation of all the forces is equal to 0, the same equation over here. As you can say this, upward direction RA minus RB plus RC plus RD, this is the one. So RA plus RD, what I got is this. Now taking momentum at this point A, as I said that B 8681 into 600, since it is a clockwise, I can consider this as a clockwise towards this point, and here point C, it is an anti-clockwise which will be moving towards this point A. So I call this as a 5415 into minus 5415 into 500 plus 600. Again this one anti-clockwise. So RD into 400 plus 500 plus 600. That is what I had given over there. So while solving this, what I got RD and RA is, RD I got a minus value, minus 498.2811. So I am going to change this RD value, right? So I can remove this. So since it is what all the initial assumption is wrong according to this. So then RA is 3763.087. So this is what value I got. Now in order to find the bending momentum over here, similar one what we did in a vertical bending momentum, the line over there is similar of that shaft over there. So bending moment at point should be surely 0. Now when it comes to bending moment at point B, as I said that, as I will considering a left side or a right side. So I will be considering at this particular point the force over here, which is 3763 into 600, right? So it is a plus. So this is what the value I got. So for which it will be 2257852, which is plus again. I am going to mark it over here. Now at this again this point C. So you can see here 3763.0877 into 600 plus 500 minus, since it is an anti-clockwise over here, this point which will be 8681 into 500 minus. So that what I can do over here. Because so yeah, I modded the whole equation over here. So while doing this, whatever the values that I got is minus 201512. So I am going to mark it minus since below this line, since it is a minus. Now surely at the D it should be 0. Now joining all these lines what we had, so and shading it out, this is what they represent the horizontal bending moment. Now once we know the vertical and horizontal bending momentum, next would be the where would you have a maximum bending momentum, whether it's in a vertical or on a horizontal. Let's try to analyze this. So for the resultant bending momentum at B, at point B, we do know that we do have one maximum bending momentum at vertical and one is horizontal. Then the equation would be MB at that point. is the square root of mvh whole square plus of mhb whole square. So vertical and horizontal bending moment at this point. Now substituting all the values over here. So what I got was momentum was this 3281536. In a similar way, the resulting momentum at C. Now substituting again all the values with the same equation. Right, what all I got is 4370362. Whichever is the maximum, that will consider the maximum bending moment. As you can know very well that the maximum bending moment surely will occur at C. So therefore, the momentum that I am going to consider in order to design this particular case is 4370362.26 Newton mm. So once I know this, I know the basic equation of the diameter of shaft. I will substitute all the values as if you know CM, CT is already given to me. So now substituting everything into this particular equation, whatever the diameter that I got in this particular case is 95.4986 mm. So in this case, one more thing need to be determined, that is angular deflection. So this angular deflection can be derived directly from an equation which is of 3.2 of page number 42. As you could see here in this page number, the equation 3.2, what it says is theta is equal to this equation. Now you know all the values given over here, substituting in this particular equation, the value that I got is 0.04753 degree. So you can see here, the shaft diameter what I have assumed is 100 mm, because in a previous it's 95 point something, so I'm gonna approximately take it as 100 mm and substituting in this value. So this is the angular deflection what we had. So this is how the case to be solved when the gear and pulley have been loaded on a single shaft. Thank you.